you got anything. That quiz tomorrow is 5-1 through 5-4. That's kind of a clue as to where you should be in the homework. Say it.
5-4.
5-1 through 5-4. Okay. If there's oh, let me get these back while you guys are thinking about questions. Jeff. Eric. Crystal. Serena. Chris. You gave me these this morning. We only get one shot. Farad, it's not here. Ben's not here. Okay. Rayanne's not here. Yeah, let's just go. All right. Is there anything from homework before we get back into what we were doing last time? Yes.
Number 65 on section 5.3. Yeah.
So this is just reminding you, I like problems like this where it tries to keep alive certain ideas. So they give you P of X, whatever it is, right? This is the one. 3x squared minus 2x plus 7, right? And then they ask you what's P of something. P of 4. Well, how do you figure out what P of 4 is? If P of X is that stuff with an X in it, what's P of 4? It's like a 4, yeah. Yeah, it's just reminding you what function notation looks like. 3 times 4 squared minus 2 times 4 plus 7. Do the same thing with 0 for P of 0. I like it. So a function can be anything that passes the vertical line test. And polynomials end up looking like this kind of thing, right? So they can be represented with function notation. And then it's just substitution, whatever number they put in there. You guys with me? No? Yes? Maybe? Sort of? Okay. Anything else from homework stuff yet?
53104.
Oh, yeah. All right. So this is one, let's see. Asking for the graphing calculator.
I just don't understand how to put it into the calculator.
What?
At least I don't know. So I have to really do it.
Let's see, I gotta turn this dude on. Where are you? Is it over there, Billy? Since I'm putting this up here, I might as well show you a couple things. Let's see. Yeah, so that light orange. Oh yeah, that's the. That's from the outside. All right. Change this over. Okay, so watch this. So this problem says, where'd it go? Was it 104, right?
Yeah.
There's 104, it says to use that function. So does anybody remember what button to push just to get something into the calculator to work with?
Y equals.
Y equals. In fact, that f of x, that took the place of y, right? That's y equals negative x to the fourth. So negative x, here's your x button, to the fourth. So far there's negative x to the fourth over, where'd it go? Plus 2x cubed minus 10. Ooh, there you go. Oh, I changed that. Oh. Okay, so there's the function in. Is that cool? That's how you just put a function in for the calculator to graph and do stuff with. If I hit graph right now, it's probably going to look freaky. Well, no, it's not too freaky. But see all this stuff they gave you? So they want the x's to go from negative 5 to 5, and they want the y's to go from negative 30 to 10. They're trying to help you so you can see the whole graph, or enough of it. So if I go to window, right down there, window, I can make my x's go from negative 5 to 5, and my y's go from negative 30 to 10. Hit graph. Give it some time. And there you got the little bumpy graph. Little bumpy graph. Aw. And then you can answer whatever questions they ask. Is that cool? Is that right? That window button allows you to directly control what part of the XY you see. So what if it was a parabola that opens down and it started at negative 30? I'm not going to see that until I tell the calculator, hey, look down around negative 30, negative 40, negative 50, so I can see the damn thing, right? That's basically what's happening here. It's something, it's not a parabola, but it, it starts somewhere and it goes down. So if I'm looking too far up, I'm never going to see it. Maybe. So that's the window thing. I can tell it, hey, look further down. That's why I made y min, the book made me make y min negative 30. Now I can see it, because it's way down there. Yes? Totally. X min has got to be smaller than X max, or it's going to give you an error, right? And the y's have to relate to what you want to happen on the y-axis, right? So if I put in here 5, negative 5, and try to graph, it's going to go, what the shit? Window range is all freaky. Like, oh, I'm sorry, man. I went from big to small. I can't do that. How are you guys?
Is that a homework question?
Yes.
What's the answer?
Well, the question is, let's see. Use a graphic calculator to graph and estimate its range.
So is that like the
Yeah, you got to use that sucker.
Oh, okay.
Looking back at the graph again. Oops, let me make this better. Negative 5 to 5. The range is looking at which axis? The range is looking at the y-axis. How far down the y-axis does it look like this function goes? Negative infinity. All the way up to, and this is why the problem says estimate, all the way up to whatever the hell that is. So you can just estimate. You just estimate what that looks like. You can count the tick marks, right? Got it. Maybe. I wanted to show you, I'm not gonna, alright, wasn't planning on showing this, but look above this x to the negative 1 button. What's x to the negative 1 gonna do to something? Like if I push 4, and then I push that button, it's gonna be 4 to the negative 1, which is what? 1/4, so the calculator's going to tell me 0.25.
Yeah.
So 4 to the negative 1, 0.25. Amazing, right? Because what does it do? That negative 1 button is a reciprocal button. All right, that's not even what I want to talk about. Look above that button. What word do you see? Frickin' matrix. So if you hit second matrix, you get some really, really freaky looking stuff. If I go over to edit and pick one of these guys, these are all names of matrices, so I can pick one and create it. So, for example, let me see if I can do this without giving somebody away. Yeah, here we go. There's a problem for the quiz, right? How big of a matrix do I want? How many rows are there?
3.
And how many columns do I want? No? 4. So I could put in here 3 by 4, and then I could just fill it up. 1, 1, 2, 9, negative 1, 2, negative 8, negative 27, 2, negative 5, 1, negative 8. Woohoo! Then, if I go back in, I can do math to it. And I don't know if you guys remember this. I might have said this really quick or something. But what we do when we do the whole thing you had to do today on the quiz is called row reducing. And the whole name of it doesn't really matter that much, but it's called row reduced echelon form. Holy shit. So when I get it 1, 1, 1 with the zeros, that's officially called row reduced echelon form. The only reason that's important right now is if I go to where it says RREF, row reduced echelon form, and then I go tell it, hey, do that to A, there's the answer. What? Now, of course, the fact that calculator can do it is not impressive at all. The fact you might know what buttons to push, not impressive at all. But, you know, in the future, you got a way to check your work. Check your work. Okay? Cute. Anything else from homework as you guys quickly copy down the answers? No? Too bad. Anything else from homework stuff? Okay. So let's get back into where I left off. Oh, you missed everything there. Sorry. You should be here anyway. So last time we did something that sounded so exciting, the long division of polynomials. Today I'm going to try to teach you a shortcut for certain problems. There's a beautiful shortcut. So let's remember what this thing is. Let's do 2 problems here real quick. This is kind of really want you guys to see something. There's something missing that I should put in there to make this come out right. So when I write a number, for example, put this on the side, don't even write this. When I write this number, what's the 0 represent?
Hundreds place?
It represents that there are no hundreds. We have built in, and if I say 1,024 divided by 7, you're not going to do this, are you? You're not going to get the right answer for this shit, are you? You're supposed to put that 0 in there. What the hell? So what am I missing on the top? What now?
A 1?
No? Do I have some x cubes?
Oh, X
Yes.
squared.
Do I have any x squares?
No.
No. So there really is a 0x squared there. So when I write this, oh shit. What's up? Really, it's not like, oh, somebody else remember. It's because the 0 is here. If I didn't put the 0 there, would I get the right answer? No. Okay. Over here, to be honest, you don't absolutely need it, but it helps you line things up. So watch what I mean. Let me see. Some of you guys might not have been here. I don't know. So you're like, what level of hell have I entered? But how do I do any long division? X times what is x cubed?
X squared.
X squared. X squared times x. Thanks for the help. X squared times negative 4.
Negative 4x squared.
So you see how now you have a place to put that? You see what I mean? If you didn't do that, you might accidentally add things that aren't even like terms. But now that I put this here, I have a place for that to go. All right, let's finish this up. What's the next step on long division? Subtract, which means change the signs. Change the signs. These cancel like they always have to. No x squares plus 4x squared, 4x squared. Bring down the negative 2x. All right, let me stop here for a second. I hope that's something you guys realize. We're doing exactly the same steps, as always. Doesn't feel like it because we've got a lot more to write down. There's all these x's, but we're doing the exact same steps. X times what is 4x squared?
4x.
4x. 4x times x, 4x squared. 4x times negative 4. 4x times negative 4. Negative 16x. And then I subtract, change the signs. Every step we've done is the same step you did with long division of normal numbers, right? Why should I expect that? Because variables are numbers. They have to act the same. They have to. These kill each other like they should. Negative 2x plus 16x. And then bring down to 1. X times what is 14x?
14.
14. 14 times x is 14x like we just said. 14 times negative 4. Negative 56. Then I
Change the sign.
change the signs. What do I do with this 57?
It's going to be 57 over 6 minus 4.
57 over
X minus
x
4.
minus 4. Okay, I like it. So this is where the Heinz 57 came from. 57. This is the formula. I did it. No. Okay. That is gross. Right? If there would have been a 2 right there, if there would have been a 2 here, what would have been different right there? All right, let's do it. Let's do another problem. I'm going to do both of these in the shortcut way. And I want to point out why the shortcut works. So let's do this. Let's do a shorter one. Sure. I like it. You guys try that one. Nothing's missing right on the top, so you don't have to worry about that 0 thing. Okay. So x times what is 2x squared? 2x. So real quick, why was this a 1 right here? Because there's a 1 right here, right? Now be careful. It's because I'm dividing by 1x, right? So if I'm ever just dividing by 1x plus or minus something? Won't the first coefficient just be whatever the shit that is? I really want you guys, if this would have been x, blah, 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 and 3x squared, wouldn't this have been 3x? Would it start with a 3? So if I'm dividing by something with a 1 in front of the x, the first number is just going to be whatever the hell number that is. So this shortcut that we're going to develop after we finish this problem needs the bottom to look like this. 1x plus or minus something. If that's what the bottom looks like, you can use a shortcut. Shortcut's really powerful, really kick-ass. Normally when that happens, it means it only works in certain situations. And that's why it's so powerful. It's beautiful, but you can't always use it. Damn it. So 2x times x. I'll do 2x times 2. 4x. And then you change the signs. If these ever don't cancel, you are doing something wrong. This first piece always has to go away. And then x minus 4x. Bring down the negative 4. X times what is negative 3x? Negative 3. So you get negative 3x minus 6. Change the signs. Right all over your hand. Beep. Negative 4 plus 6. 2. So this would be plus. Same thing as putting 7 and 5 sevens. It's the same exact idea. So here's what the shortcut. These both can use the shortcut. So next to this one, I'm going to put its shortcut. So notice, all right, here's my attempt. Has everybody got all this down? All right, I don't want to do too much of this, but I thought, for this one, let me see. Just what is kind of the most important things everywhere? Why did we put a 4x there? Because that was a 4, right? Did it even really matter these were x squares? Not really. All the variable shit is just extra writing I don't need. So the way this shortcut works is it says, everywhere there's an x, just take it away. Just make sure this is in the right order, and then take all the x's away. All I care about really are the numbers. There's what's telling me what to do. Those numbers are what's telling me what to do. So watch. So the way to write this guy now, by the way, this shortcut is called, you're going to love this name, synthetic division. No idea why they really chose to call it that, but I won't. And here's the problem we can take care of. What's the easiest thing to forget in this whole thing? Curious about what your answer would be, but no. The easiest thing to, well, that's 0, I understand, that's a good point. But for any problem, what's the easiest thing to forget? Changing the sign. So watch this. This is kind of cool. So this method says, don't put x minus 4, just put the negative 4, and then go, wait, let's change the sign right now. Let's change the sign right at the beginning so I don't have to remember to do it. So let me put a positive 4. So what am I going to put down for this guy?
Negative 2.
Negative 2. Kick ass. Okay. And over here I'm going to put just the numbers. This is the coefficients. 1, 0, negative 2, 1. Separate him somehow. There we go.
Why'd you put a positive 4?
So, I'm taking away the x's. They don't matter. Right? Because whatever number this is going to be what the first number is in the answer. So I don't even care that there's x's there. And then, so there's a negative 4, but I said, well, instead of changing the sign each time, let me change the sign right off the bat.
And you said this only works when there's...
It only works when the bottom is x plus or minus a number. Like x minus 4 is good, x plus 2 is good.
But it can be 2x.
2x plus 5.
No,
You can do some weird shit to make it work, but I'm not going to push that on you. Just say no, kids. Stay with me now. Once you see this go, I can make the analogy between what we did and what you see here. So now watch, I really want this to kind of make sense. We sort of reorganize the whole thing, and it's a lot quicker. So what's going to be the first coefficient of the answer is whatever number that is. Why was this a 2? Because that was a 2. Right? We talked about that a minute ago. So what gets this thing rolling is bring the 1 down. So this last row is going to be all the coefficients of the answer. Now just stay with me. What did I do with when I put that 4 there? Did I do 4 times 1? To get 4x and let me see, I'm sorry. I'm going backwards. 1 times 4 to get there. So watch this, watch it. 1 times 4. 4. 0 plus 4 is 4. Now look, right here. 0 plus 4 is 4. That's where we are. So what should show up next? That should show up next. 4 times 4 is 16. Negative 2 and 16, 14. Negative 2, 16, 14. So this process takes all the x's out of the way, focuses on the coefficients. So what you do is you bring the 1 down, multiply, add, multiply, add, multiply. 4 times 14 is, of course, that 56. 56 and 1, 57. So now I feel comfortable saying this. I didn't want to say what I'm about to say before I did this, but now I feel comfortable with saying it. This is a lot like a matrix. In that a matrix takes all the variables out of the way, just focuses on the numbers, because that's what tells me what to do. If I would have said that at first, you guys would have been like, I hate this already, because I hate matrices. Screw you, Jeff. But this isn't that bad. But now you see, it is sort of like that same idea. You have to know how to interpret the answer, though. What was the highest? Now watch. Isn't this like x squared, x cubed divided by x? Can't even see that. X cubed divided by x? Doesn't that make sense why the answer came out to be x squared?
Yeah.
So whatever the power was, the answer is going to be 1 degree below that. So that was an x cubed. So this says 1x squared plus 4x plus 14, and that's the remainder term. I'm assuming he has like another thing to worry about. We should be like, oh sweet, this is really cool. Makes this a lot quicker. No? Alright, let's do another one. Let's do this one. I'm going to erase this first thing and do this up here. And then I got a little handout with all the steps kind of described. So I don't really like hockey, but I call this the penalty box just because. So what am I going to put in the penalty box for this problem?
-2.
-2. Take the x away, change the sign. That's related to changing the sign over and over. Let's just do it once at the beginning. What am I going to write here next to it?
2, 1, and -4.
Kick ass. Just the coefficients, making sure that you didn't miss anybody. We didn't need a 0 because we got everybody. And then what gets me started is that number drops down. That's related to that being this being a 2 because that was a 2. So whatever that is, it just comes down and becomes part of the answer. If that would have been a 7, what would I put here in the answer? Freaking 7. So that step is just saying, since I know I'm dividing by 1x something, whatever that number is going to be a part of the answer. That's the key why it only works with that type of thing on the bottom. And then what do? Multiply, add. Multiply, add. Is that the same stuff we got? 1 minus 4 is -3. 1 minus 4 is -3. -4 plus 6 is 2. -4 plus 6 is 2. But it just cuts away all the extra writing of bullshit, right? that's the part that's a lot like a matrix. So what's the answer going to be? Well, it started off as x squared, so this is going to be 2x
minus 3.
minus 3,
2 over x minus
2 over x plus 2.
Plus 2.
It's always the opposite side of that guy, which is that the same thing we got? Think of it. Sorry. I know I'm not the average student, but I remember when I first saw this, I was like, sweet. Yes, sir.
So you kind of have to do the long division.
No, you don't. No. All right, let's do one without any long division. Let's just do one straight into synthetic. I love that question. The only reason I did this and then this was to show you where things were, so you bought into it. We know this is true, so this better say the same shit. What's up? What's up?
Keep fighting to it all.
What part? Do you see the parts I'm trying to point out?
No, I understand that whole thing, but it just makes more sense when the long division.
Oh, I see. All right.
Yeah.
All right, that part you get.
Like, I don't know how to get there without.
So you ready? You ready? Now watch. Let's do this. Let's do this one. Let's see if I can get you to really buy it. So what if I had this? Yeah. Long division would be a problem where you have to like turn your paper this way. Synthetic division doesn't give a shit. It's just got a few more columns. The idea, multiply, add, multiply, add, multiply, add, multiply, add, is quick. You don't have all this extra bullshit to bring it down and write all the x's. So let's see. What's going to go in the little penalty box?
-1.
Am I missing anybody?
Yeah.
So I should put right here. Just to remind myself, right? No x's. You guys see that? I need a placeholder.
Yeah.
Huh?
X
And a fourth power. Shit. So I need plus 0 x to the 4th. Okay. What's that? You guys were cool when I did it over here, the first problem we did, but now not cool anymore. Our number system, again, this was the example I had earlier. If I did this problem to answer this, would I get the right answer? No. And of course, to us, we're like, well, duh, dude. 124 is not the same thing as 1,024. Right? So our numbers have a way to show that they're missing something. I'm missing hundreds, so that's why there's a 0 there. Babylonians had no symbol for 0. They would, if they wanted to write 1,024, they'd write, actually the symbol 1 looked like this, and then they have some space, and hope to God everybody understood. Do you see what I'm saying? They didn't have a symbol for 0. So here, I'm missing all the x to the 4th. I don't have any x to the 4th. So I put a 0 placeholder there. So how many? So I have how many x to the 6th? 1. How many x to the 5th? How many x to the 4th? None. How many x cubes? 4. How many x squares?
-0.
-1. How many x's? None. How many ones? 7.
So there's like a column that's like a 6, like x to the 6th, and then x to the 3rd, you would have to fill in.
Yes, you'd have to put a 0 for the 5th, a 0 for the 4th. You put a 0 for everybody you're missing. I like it. It's sort of like, you know, if I had x plus y plus z equals 2 and x plus 3z equals 5, what would that look like in a matrix? 1, 1, 1, 2. What would this next row look like? 0, right? All right. It's the same idea. It doesn't matter if it's letters, numbers. I gotta have a placeholder to say, oh, I got none of these shit. This is long. Do you guys understand how long this problem would be in long division? I mean, then the long really means it. But now look, all I had to do is add a few more columns onto this. So how do I get started? Bring the 1 down. -1 times 1 is?
-1.
-1. Add.
-3.
Multiply.
3.
Add.
3.
Multiply.
-3.
Add.
1.
Multiply.
-1.
Add.
0? Oh.
Multiply. Add. Multiply. Add. So if I add more shit on, the process doesn't become longer really at all.
So you just multiply against whatever the
Yeah, bring this number down. Multiply, add. Multiply, add. Multiply, add. Multiply, add.
Okay.
Let me, all right, I like it. And when I give the handout out too, I try to show that. You'll see if it makes sense on there. How would I write the answer? What power would this be the coefficient of? Fifth power. Was it sixth power? I divided an x away. So it'll be 1x to the fifth,
Minus 3x.
3x to the fourth,
Plus 3x.
3x to the third,
1x squared.
x squared,
Negative 2x.
minus 2x,
Plus 2.
plus 2,
Plus
And then
5 over.
5 over
5
x
over
plus
x plus 1.
Okay.
Wow! So that long division would have been heinous.
This is more satisfying than interesting.
I know, it is. That's why I didn't want to say the connection before we did a problem. Now you guys are like, okay, it's like the best part of the matrix. Okay. If I would have said the first, you would all like, screw this shit already. I'm not going to pay attention. All right. Maybe. If you guys get pretty good at these or something and you have, for example, if there was a 2x plus 1, you could actually still do it. You'd have to use a negative 1/2 here, though. You see what I mean? So we don't want to throw fractions in the middle of learning something entirely. What time? What time to go? Okay. What else was I going to show? Oh, let me give you this handout. Now that we've done a few of these, maybe this will make more sense.
That's how you start.
What is all this stuff? Shit.
Write that down. So now you need more.
Sucks.
Yeah.
For only me.
Adam. And you put that down in there, so you
Real quick, before you leave, a little preview of where we're going. Somebody help me out.
4x
4x
plus 8.
So if I told you these both have a 4, you see what I mean, right? Of course they do, because we just gave them both a 4, so a factor of 4. So we just freaking multiplied them with 4. Of course they got a 4, Jeff. So then if I say, okay, what do these both have? What are they? Yes. So can you write it in this form then? What would it have been? It would have been 6 times what?
X plus 3.
Yeah, so let me put it down here. 6 times x is 6x. 6 times 3 is 18. So officially we can call this undistribution. Well, that's stupid. We call this greatest common factor. So it's our first type of factoring. So the next chapter is all about factoring stuff. Yeah. So I think I don't have any. So real quick, last one. Sorry, that was weird. So do you see how there's a number that definitely they both have?
Yeah.
5.
5 and x.
And how many x's do they both have?
X squared.
Yeah. If you try to take out an x cubed, isn't he gonna freak?
Yeah.
So you're kind of like the fair tax man. You don't take more than somebody's got. Right? So he can give 3, but he can only give 2, so you just take 2 from everybody. So you can argue about, I don't want to get into politics about taxation and bullshit, but anyway. I can take 2 x's out. Now here's where things get weird. What goes here?
1.
Good. 5x squared times what is this? 1.
4x.
4. Had 3, took 2, so I got 1 left. So GCF is the easiest form of factoring. So next time, tomorrow, we'll get more into factoring stuff. Blue line. Thank you.